And one thing you're going to want to do with that next page, or when you're doing the classwork by yourself, is to make sure that you have those perfect cubes right near you. So when you're doing the problems, you'll have these. So let me slap this on down here, get that in focus. All right, so let's dive right in. I'm gonna do mostly the odd questions on this paper here. So if we take a look at number 13, this time we have a cubed root and we have a variable on the inside. So we have x to the third power. So the key thing we're gonna be looking for are triplets when we're dealing with variables. So if I take a look at number 13, just like we did yesterday, if I were to write this out, x times x times x, how many triplets would I have? Well, I would have one set of triplets. And so my answer would just simply be x. Let's take a look at number 15 here. I've got, under the radical sign, I have p to the 7th power. Now I can write this out 7 times, so p times p times p. A lot of p's here. All right, one more. And then I'm looking for my triplets. So I'm gonna circle one set of triplets, two sets of triplets. Those triplets get to go outside of the radical sign. So I'm gonna have p to the 2nd power. And then on the inside will be that lonely p. So p squared, cube root of p. Number 17. With number 17, now we're dealing with a number and then also the variables. So if I take a look at number 17 here, let's deal with the 512 first. And actually that's going to be one of the easier things to deal with because if you look at 512, there's something special about 512. And that something special is if I were to find the biggest perfect cube, that biggest perfect cube would actually be 512. So they really just want you to take the cubed root of that. Let me straighten that out here for us. So if I take the cubed root of that, I'm going to end up with 8. So I don't really need to even break that down much further. But what I can break down are those variables. So let's go ahead and give that a shot. So I have x, and then I have a y to the 10th power. Well, if I look at the x, there are no triplets here. It's just the lone x. So that lone x is going to stay on the inside. But what about y to the 10th? So I could write that down 10 times, which might be a little bit difficult if, for instance, you have some bigger numbers. But let's just do this one here. So I have one set of triplets, another set of triplets, and then a third set. All right, so on the outside, I could have y to the 3rd power. And on the inside would be that lonely y. Well, I guess it's not that lonely, it has the x right next to it. So we're good to go. Although we have to remember to write that little 3. It's very important to have that little 3. Okay. So if I take a look at number 16 here, so we got a couple of things going on here. We've got some variables. We also have a negative cube root that we can break down as well. And I'll try to show you a little bit of a shortcut with the variables versus having to write them down so many times. So let's dive right in here with the negative 32. So this one I'm going to have to break apart. As I told you in the previous problems with this, don't forget your little cubes. And also, since I have a negative number under the radical sign, I'm probably going to have a negative perfect cube. So in this case, the biggest negative perfect cube that can go into it is going to be, maybe you guessed it, I don't know, negative 8. Okay? And then I'm going to have negative 32 divided by negative 8, which is just going to give me a 4. Now, when I simplify this a little further here, the cubed root of negative 8 is just going to be negative 2. And with the cubed root of 4, as you probably already guessed, that would be a decimal. So let's go ahead and keep that the same here. Now, let's go ahead and tackle these variables here under the radical sign? Well, I have p to the 17th power. Now, really, I don't want to go ahead and write that 17 different times. That would just be a pain. So one little shortcut that you could do, since I said the focus today is on triplets, well, I could just do 17 divided by 3. And if I do 17 divided by 3 in my calculator, I'm going to get a 566, all right? So I know I'm going to have at least 5 sets of triplets, okay, as far as my p's are concerned. So I would have p to the 5th power, and I will have 2 leftover. So I'm gonna have 2 leftovers here. So let me go ahead and I'll have p to the 2nd power in here. Now I'm gonna bring over my numbers that I wrote because I didn't give myself enough space to write in the variables. So I would have the -2 here. And then of course the 4 from the previous part when we broke down that -32 over here. So we've got one more letter to deal with, and that other letter happens to be Q. And so with the Q, I could write it out and get my triplets like I did in the previous problem, or I could just take that little 8 and also divide that by 3. And what you'll find is that you'll get 2 points such and such. So I know I'm gonna have at least 2 triplets. And on the inside, I'm gonna have some leftovers. I'm actually gonna have 2 there, okay? So you could write it out all the way, just like we did in the previous 3 problems, and just find your triplets, you know, and then whatever's left over stays under the radical sign, or you could just divide by 3. I think it's a little bit easier to divide by 3, especially when the numbers are pretty big, but I leave it up to you as to what you want to go ahead and do with that problem. All right, so our last example that we're gonna do together here is number 21. Once again, we have a negative number here under the radical sign. We have a negative 48. And so I need to find out what's my biggest perfect cube that can go into negative 48. And so if I were to go ahead and do that, it looks like my biggest number, we might have to do a little trial and error here. But I think it's just going to be 8. So if I put it in my calculator, yeah, looks like 8 and 6 are going to be my numbers here. But remember, I'm going to want that to be a negative 8. So that's going to be very important as far as our final answer is concerned. And then when I do negative 48 divided by negative 8, I'm going to end up with a positive 6. Okay? When I break this down here and I do the cube root of negative 8, I'm going to end up with a negative 2. As you probably guessed, the cubed root of 6, that would be a decimal, so we can just kind of keep that the same. But we're still not done here because we can't forget about that little 7 that's hanging out on the other side. So I'm going to go ahead and bring that down. So I'm going to have 7 times a negative 2, which is going to end up with a negative 14 here on the outside. And then I'm going to have my cube root of 6 on the inside. Now I'm giving myself a little bit of space because the one thing we haven't dealt with just yet are those variables here. So let's dive right into that. I see the lonely x, so it looks like that's going to stay on the inside because there's no triplets there. I have y to the 9th. Once again, I could write out all of my y's. That's perfectly fine. Or I could just divide by 3, and I would end up with 3. So I'm going to have y to the 3rd. Those triplets get to go outside. Same thing with the z's here. I could just divide by 3, and then I'll have 1 set of triplets. Or you could just go ahead and write them. So let me just write them over here so I need a little more space. And then you'll find out there's just 1 set of triplets. They go on the outside, and on the inside are going to go with the leftovers. So I'm going to have z to the 2nd power on the inside here. All right, so that wraps up this lesson here today. So don't forget to go into Student View or on Microsoft Teams to go ahead and finish your classwork. And if you have any extra questions, feel free to reach out to us during our respective office hours. See you again for the next video.